High above us in the Earth's stratosphere lies a delicate yet vital layer of gas, the ozone layer. Invisible to the naked eye, this protective shield plays a crucial role in safeguarding life on our planet. It filters out most of the sun's harmful ultraviolet radiation. Situated in the Earth's stratosphere, it is approximately 10 to 30 kilometers above the surface. Ozone shields the Earth as a natural sunscreen, ensuring that the delicate balance of ecosystems is maintained, allowing life to thrive. The layer is primarily composed of ozone, a molecule made up of 3 oxygen atoms. Without this protective layer, these rays would reach the Earth's surface in much higher concentrations. This unique molecule possesses the remarkable ability to absorb most of the sun's harmful ultraviolet radiation. Particularly UVB radiation can have devastating effects, causing skin cancer, cataracts, and damage to the immune system. Prolonged exposure can also lead to harmful effects on marine ecosystems, affecting plankton and organisms that form the base of the food chain. Ozone shields the Earth as a natural sunscreen, ensuring that the delicate balance of ecosystems is maintained, allowing life to thrive. It is in a constant state of formation and destruction. Ozone molecules are continuously being created and broken down through a series of complex chemical reactions. This delicate balance is maintained by a complex cycle of chemical reactions involving oxygen and sunlight. When ultraviolet light strikes oxygen molecules, it splits them into individual oxygen atoms, which can then combine with other oxygen molecules to form ozone. However, human activities have disrupted this natural balance, leading to a thinning of layer and the formation of the ozone hole. Chemicals such as CFC have been particularly damaging, depleting the layer that protects us. The ozone layer is a unique and irreplaceable feature of our planet. Its formation is a testament to the intricate interplay between the Earth's atmosphere, sunlight, and oxygen. While scientists have a deep understanding of the chemical processes involved in ozone formation, replicating this process on a large scale is beyond our current capabilities. The ozone layer is a delicate and complex system that has evolved over millions of years, and its preservation is essential for the well-being of all life on Earth. In the 20th century, human activities, particularly the release of man-made chemicals, began to have a detrimental effect on the ozone layer. These chemicals, known as ozone-depleting substances, include chlorofluorocarbons, halons, and hydrochlorofluorocarbons. CFCs, once widely used in refrigeration, air conditioning, aerosol propellants, and industrial processes, proved to be particularly damaging to the ozone layer. When released into the atmosphere, CFCs rise slowly into the stratosphere, where they are exposed to intense ultraviolet radiation. This exposure breaks down CFC molecules, releasing chlorine atoms. Chlorine atoms act as catalysts, triggering a chain reaction that destroys ozone molecules. A single chlorine atom can destroy thousands of ozone molecules, amplifying the impact of CFC emissions on the ozone layer. The most dramatic manifestation of ozone depletion is the ozone hole that forms over Antarctica every spring. This phenomenon has been observed since the early 1980s and has become a significant environmental concern. The ozone hole grows to an area larger than the continent itself, affecting the entire southern hemisphere. This thinning is caused by a combination of factors, including the extreme cold temperatures, which are unique to the Antarctic region. The drop in temperatures facilitates the formation of polar stratospheric clouds, which play a crucial role in the depletion process. The presence of polar stratospheric clouds is essential for the chemical reactions that lead to ozone depletion. These clouds provide surfaces for reactions that would not occur under normal atmospheric conditions. Additionally, the accumulation of ozone-depleting substances such as CFCs and halons released by human activities exacerbates the problem. These chemicals can persist in the atmosphere for decades, gradually making their way to the stratosphere. During the Antarctic winter, a vortex of cold air forms over the South Pole, isolating the air within it. This vortex, known as the polar vortex, acts like a barrier, preventing the mixing of air from outside the region. Within this vortex, polar stratospheric clouds form, providing surfaces for chemical reactions that convert inactive chlorine compounds into more reactive forms. These reactive chlorine compounds are the primary agents responsible for the destruction of ozone molecules. When sunlight returns in the spring, it triggers a rapid chain reaction that destroys ozone molecules, leading to the formation of the ozone hole. This process continues until the polar vortex breaks down, allowing ozone-rich air from lower latitudes to mix in and start the slow process of recovery. The depletion of the ozone layer has profound implications for life on Earth. Increased UV radiation reaching the Earth's surface poses significant risks to human health, plant and animal life, and marine ecosystems. For humans, increased UVB exposure increases the risk of skin cancer, cataracts, and suppression of the immune system. It can also damage plants, reducing their growth and yield, and disrupt delicate marine ecosystems. Phytoplankton, the base of the marine food web, are particularly vulnerable to UV radiation, and their decline can have cascading effects throughout the ecosystem. The discovery of the ozone hole and the threat posed by ozone depletion galvanized the international community into action. In 1987, world leaders signed the Montreal Protocol on substances that deplete the ozone layer, a landmark environmental treaty aimed at phasing out the production and consumption of ozone-depleting substances. The Montreal Protocol is widely regarded as one of the most successful international environmental agreements ever negotiated. It is a testament to the power of scientific collaboration, political will, and collective action. The treaty's success demonstrates that humanity can come together to address global environmental challenges. Nations came together, setting aside differences to tackle a common threat, making significant strides towards healing our planet. Thanks to the Montreal Protocol and its subsequent amendments, the concentration of ozone-depleting substances in the atmosphere has been steadily declining. As a result, the ozone layer is showing signs of recovery, and the ozone hole is gradually shrinking. Scientists estimate that the ozone layer is on track to return to its pre-1980 levels by the middle of the century. However, the recovery process is slow, as ozone-depleting substances can persist in the atmosphere for decades. The story of the ozone layer is a powerful reminder of our interconnectedness with the natural world. It shows how human actions can have far-reaching consequences. The depletion of the ozone layer was a wake-up call, highlighting the delicate balance of our ecosystem and the importance of international cooperation in addressing global environmental challenges. Communities also took part worldwide, showing that every individual can make a difference. It symbolized scientific discovery and collective action. Scientists played a pivotal role, providing the data and solutions needed to address the crisis. This landmark agreement showed that when humanity unites for a cause, monumental achievements are possible. It serves as a beacon of hope in our ongoing environmental journey. This demonstrates that by working together, we can ensure a healthy and sustainable lifestyle for all. From renewable energy projects to grassroots movements, collective efforts are paving the way for a greener future. As we face versatile environmental challenges, the urgency to act becomes greater. The visible impacts of climate change, from melting glaciers to extreme weather events, remind us of the pressing need for action. The lessons learned from the ozone layer depletion crisis can guide our actions. By understanding past mistakes and successes, we can better navigate the complexities of current environmental issues and inspire us to create a more resilient world. Education and innovation are key, empowering the next generation to continue the fight for our planet's health. Together, we can build a legacy of environmental stewardship.